to compare the degree of the numerator to the degree of the denominator in order to decide what your horizontal asymptote is going to be. What is the degree of your numerator? 1. What is the degree of the denominator? Also 1. So the numerator degree is equal to the denominator degree. Look in your notes. What does it say you should do for your horizontal asymptote here? Divide your leading coefficients. So we know what the degrees are. What's in front of this x in the numerator? A 1. What's in front of the x in the denominator? A 1. So those are your leading coefficients. So we should really divide them. Our horizontal asymptote would be at y equals 1 over 1, or we could really just write that as y equals 1. Now, what's nice about today is since I was able to find an x-intercept because my numerator had an x value, I actually already have a point on my graph. If we only need one point to graph, do I need to make a table of values to draw my branches? I don't think so. I think I have my two asymptotes, I have a point there, and I have enough information to know where my two branches of my hyperbola will be. So I'm going to go ahead and draw my hyperbola. Remember, the branches should approach your asymptotes. So you should be getting closer to your asymptotes in both sections, but they have to be catty-corner or diagonal from each other. Okay, so that works out pretty nicely, actually. We can still do domain and range today. Remember, domain is everything that you can put in for x and still get answers back out for y. Do you have any restrictions to your domain? Are there any x's that don't work?
0.
X cannot be 3. Okay, you're always going to include a vertical asymptote in the restriction to the domain because that's the thing that could make your denominator equal 0, and we can't have undefined answers. Okay. What about a restriction to your range? Is there anything your y will never be? Y will get really, really close to, but will never actually be 1. Because that's our horizontal asymptote. So you can see on the right side it's getting really close to 1. On the left side it's getting really close to 1, but it's never actually going to be 1. So we'll say y is not equal to 1. And because we checked at the very beginning to see if we could factor either the numerator or the denominator, but we said we couldn't, and nothing canceled, we again have no holes. Does anybody have any questions? The big difference there from yesterday is we are able to find an x-intercept on this one because it has an x value in the numerator. Okay, and we set that equal to 0 and we could solve. And also our horizontal asymptote, this time we had equal degrees, so we had to use that ratio of our leading coefficients. Okay, let's do another example. X plus 3 over x squared minus 9. Now, when things start to look like you have more x's, you've got x's in the numerator and you've got x's in the denominator, you always want to check for factoring first. So does either the numerator or the denominator factor here? Can you factor x plus 3? No. Can you factor x squared minus 9? Yeah, that was on your quiz on the back side. Okay. X squared minus 9 is the difference of perfect squares. So that will factor out to be x plus 3, x minus 3. We've talked about the difference of perfect squares numerous times. A squared minus b squared is equal to a plus b times a minus b, where a and b are the square roots. Now, what do you notice once it's factored? You could cancel something, right? So what happens, and you can use your notes to answer this question, what happens when you can cancel a factor in the numerator and denominator? When the numerator and denominator share a common factor, we have a whole. Okay, so this is going to be our point of discontinuity. Anytime you're able to cancel, that means you're going to have a whole. Now, the whole is not like an asymptote. It's not a whole line. It's just a single point. So in order to find out where the whole is, we need to find the x-coordinate of the whole, and we need to find the y-coordinate of the whole. In order to be able to do that, whatever factor you canceled, set that factor, x plus 3, equal to 0. Solve for x. So x equals -3. So for my whole, I'm going to have a whole and -3 something. Are we okay with that? Okay, use the one that you canceled. Now, to find the y value of the whole, if we were to plug this -3 back into the original equation, what would our numerator be? -3 plus 3, 0. And then what would our denominator be? -3 squared minus 9, 0. So 0 over 0 is kind of a weird thing. We call it indeterminate. We don't really know what that means, 0 over 0. So we can't find the y value by plugging it back into the original function. We're going to plug it back in. Plug x equals -3. Into your simplified function. Simplified means after you canceled the x plus 3's. Okay, so if you cancel the x plus 3's, plug -3 back into it. Okay. Now, if I look back up here and I think about, okay, I canceled x plus 3 over x plus 3, what's left over? In the numerator, I would have a placeholder of 1, and in the denominator, I would have just that x minus 3 factor. So that's what I'm going to put the -3 into to figure out the y value of my whole. So I'll do 1 over, I'll say y equals 1 over -3 minus 3. That's 1 over -6. Is everybody okay with that? Does anybody have any questions? So that means my whole is actually 3 units to the left and then 1/6 unit down, just a little bit less than the x-axis. I'm going to draw a hole there. It's going to look like a point, but it's going to be open instead of closed. And so I'm going to go left 3 and down 1/6. There's my hole. Now, to do the rest of your work, you use what's left over after you cancel the whole. Okay. So if we go back up to our x-intercepts, and we look at our numerator, all we have left up there is 1. If we set 1 equal to 0, are we going to find an x-intercept? No. 1 equals 0 does not produce an x-intercept. Okay, so I could say 1 does not equal 0. That's what's left over in the numerator, right? So I have no x-intercept. If you have a whole, you still might have a vertical asymptote. Just look at your simplified function is there anything left over in the denominator that you just said equals to 0? Well, there's an x minus 3. So x minus 3 equals 0. We have a vertical asymptote at positive 3. So this time I'll go right 3, and I won't draw a point of discontinuity. I'll have that asymptote. For a horizontal asymptote, we're going to check what? The degrees of the numerator and the denominator. What do you notice about the degree of the numerator and the denominator in the original function? They're different, right? The degree of the numerator is 1, the degree of the denominator is 2. So now the numerator's degree is less than the denominator's. What do your notes say about horizontal asymptotes there? If the degree of the numerator is less than the degree of the denominator, it'll be y equals 0. Unless there's some k value, but we don't have anything being added or subtracted on the back. So our horizontal asymptote is going to be at y equals 0. Now, that makes sense if your horizontal asymptote is at y equals 0, why you don't have an x-intercept. Because if you had an x-intercept, it would be on the line y equals 0, but there's not supposed to be anything there. Now, what's nice about this, that hole can still serve as a point to help you decide where your branches are. So do I know where my branches are going to be? Yeah. Something like this. So even though it kind of, like, we're doing maybe a little bit more work today to, like, find the hole, and we have a vertical asymptote still, and maybe even an x-intercept, we don't have to do that extra step of finding an additional point. Now, domain and range are going to be something that is slightly different from yesterday. For domain, we have to restrict all of our x values, okay, that don't produce answers. So where on your graph do you not see a point on your hyperbola for x? I don't have a point at negative 3, and I don't have a point at positive 3. So the hole and the vertical asymptote are restrictions to your domain. Okay. I don't.
Does the negative 6 not come out of the domain? Or
Not in the domain. The negative 1/6 will be in our range, because think about that ordered pair, negative 3, negative 1/6. Negative 1/6 is y, not x. Okay. And then when we do range, we'll say y's cannot be. We can include the negative 1/6 because there's really, if it's not at that hole, we don't have it. So y's cannot be negative 1/6 or our horizontal asymptote, which is 0. So now you have to add the values of the hole into your restrictions for domain and range. Okay. Does anybody have any questions about any part of that? Yeah, Faith. Mm-hmm. Yep. Negative 3, negative 1/6 is my final answer for holes. That's where it is. Let's try another one, and I'm gonna, I think, skip the next one, because if you notice this next one, can you factor the numerator for 5x? No. Can you factor the denominator, x plus 1? No. It is a factor, x plus 1. Is there anything that cancels? No. So this one will not have a hole. Okay, we'd go along our merry way doing vertical and horizontal asymptotes, and maybe finding an x-intercept there. But I want to skip to the f of x equals x squared minus 1 over x squared minus 6x plus 5. What I want you to do first is, do you first notice this one is a little bit, it looks a little bit more? Just the fact that it has the quadratic x squared. So anytime you see that, you always want to try to factor first. So can you try to factor the numerator and denominator? Do that for me right now. Factor the numerator and the denominator. Were you able to, yep. Were you able to factor the numerator? How does it factor, Sahil? X plus 1, x minus 1, that's the difference of perfect squares. And can we factor the denominator? Yeah, what does that factor to be? X minus 5, x minus 1. What do you notice? X minus 1 cancels. So that means we have a hole. I'm going to go down to the bottom, do my work for my hole. Whatever factor I cancel, set it equal to 0. So my hole happens at x equals 1. To find the y value of my hole, I'm going to plug that value of 1 into the factors that are left over. X plus 1, x minus 5. So 1 plus 1, 1 minus 5. If you plug it back into the original problem, it's not a huge deal until you realize that it's 0 over 0, and that's unhelpful. Okay. This gives me 2 over negative 4, which simplifies to be negative 1/2. So you can go 1 to the right and 1/2 down and make an open circle. That will be where your hole is. 1 to the right and 1/2 down, there's your hole. Now take a minute or two, use your notes from yesterday to decide, do you have any x-intercepts? Do you have any vertical asymptotes? Okay. What is your horizontal asymptote? I'll give you a minute or two. You're using the information from yesterday, and you're using like what's left over. What do we say for x-intercepts? Do we have one? Damon, you say yes. Where's it at?
It would be negative 1.
It'd be at x equals negative 1, because we look at any factors that are left over in the numerator for x-intercepts. So we'll say x plus 1 equals 0, that's x equals negative 1. So an x-intercept is a point, it's really negative 1, 0. go left 1, go up or down nothing so you're on the x-axis. Now the x-intercept you'd make as a closed point because it's not a hole. Do you have any vertical asymptotes? X equals 5. Set x minus 5 equal to 0, and we'll solve to get x equals 5. That's a vertical line, 5 to the right. Any factors that don't cancel out to make a hole and are left over in the denominator are still vertical asymptotes. What about horizontal asymptote? What's our horizontal asymptote? Y equals 0? How'd you get that?
Because the numerator and the degree in the numerator and the denominator are equal.
Yes, the degree in the numerator and the denominator are equal. So numerator equals denominator. What do your notes say about horizontal asymptotes when that is true? Is it y equals 0? Pretty sure that's when it's less than.
Oh, and then you just, you divide it.
You divide the coefficients, right? So this one, if you go back to the original one, we have 2 in the numerator and denominator. So we're going to divide our leading coefficients 1 over 1. And our horizontal asymptote should be at y equals 1. Now, thinking ahead to your test that you're taking next Wednesday, we're going to fill out that foldable. We're going to put some of the information from our notes on our foldable. So one of those things we'll want to put in the graphing section are the rules for asymptotes or horizontal asymptotes. So make sure that you're at least referencing your notes as you do your practice problems so you get used to that for when you come in for Wednesday's test. I think you have enough points to decide where your branches are again. We're going to approach the asymptotes. Something up there. And then for domain and range, we're going to write the things that it cannot equal. X cannot be 1, and x cannot be 5. Cannot be 1 or 5. That's the x-coordinate of our hole. That's the vertical asymptote. Notice those are the 2 answers to your denominator. Okay. Range, y cannot be 1 because that's my horizontal asymptote, and I should also include the y coordinate of the hole, so -1/2. Will not be true.